This is now my programmed arithmetic FPGA board, and if you see, it looks good. So the way it works is that these first 8 switches will represent A, and these last 8 will also represent A, and we're using 2 complement numbers, which means that if the leftmost digit is turned on, it's going to negate it. So the first thing I want to show is adding 2 positive numbers, and the easiest one to do is if I add 1 and 0. And if I do 1 and 0, so these LEDs also are correlated with what the answer would be. So if the first light on, that means when I added them together it was 1. And I can show that if I also add, let's say I added 1 on here and 1 on here, or 2, then now when I added 1 and 2, now my bit stream shows 3. So I have 1 on A and 2 on B. And now, so we know that's programmed correctly. And if you add a positive and a negative number, now let's say I make this, what's happening is I have this is 1, and now this is a negative 3. So now we're adding 1 and 1, but because of this one, it's negative, we're going to have a carryover function. This carryover function is going to go all the way over here and actually add 1 more to the digit, making it 9 digits. And if I do the same thing where I make a negative, let's say I make a negative 1 plus 0, it does the same thing. And if I add 2 negatives, then this carryover will not end at the end, but it'll still have. So now I'm adding negative 1 and negative 1, and it gives me, see, not negative 1. Maybe it's 1 and negative 1, and it gives me 1 carried over. And then to do just a thing that makes it where we have the carry over, I think I did do that because I added all of the negatives, and sometimes it carries over another 1 to show that it's negative. And that is my board.